Hello everyone. In this video, I'm going to walk you through question number 3 of our RF homework exercise, part 1. The question here asks you to use Smith charts to design a lump element network, the else matching networks, to match low with 100 minus J40 ohm to a source impedance 50 ohm. The frequency is 1.3 gigahertz. Okay, so you are going to draw the network. As I point out in another videos, you might end up with more than one answers. Okay, so now I'm going to start. I will switch you back to the Smith chart. First of all, you start with the low impedance, 100 minus J40. The first thing that you need to do is to normalize it by dividing the low impedance by 50. So this will end you up with 2 minus J 0.8. So you locate the point 2 minus 0.8. So 2 is here. Let me see. Okay, 2 is here. And then you drag along the constant Wilbur circle until you meet with point A. So this is the point, the low impedance. This is point A, right? 2 minus J 0.8. So the next thing that you are going to do, you have two options. You can either, so now we need to focus on the blue grids. Remember, this is the impedance with a view part larger than 50. So you have already learned that we need a parallel element. The first thing that you need to do is to find the parallel elements to parallel with this. So we can either go this way. So if you go this way, then you are going to use an inductor to parallel with the load. So when we do this, until you meet the the 1 plus jx circle. So this is 1 plus jx circle. So here is A, right? I presume here is B, right? For example. So this is the first step. And the next thing that you are going to do is to count how much subsistence that you need in order to bring you from A to B. So from A, right, you need to read from the Smith chart here. So here, if my understanding is correct, is about 0.1. So here is about 0.18. And here is about 0.5. So altogether, you need that much inductance. The amount of inductance that you need is 0.5 plus here 0.18, which is 0.68 J. So this is the amount of subsistence you need to bring from A to B. So I'm going to draw the schematic. So you will have a low impedance. Yeah, I will just put it like this here. So 2 minus J upon A. And the very first thing that you need is a low subsistence. But now you're going that way, right? So it's minus J 0.6A. So I hope you can read my handwriting. The next thing that you will need is to find out how much reactant you need in order to bring from uh, this point B to the origin. So you scan this way, drag along the 1 plus 3x circle in an anti-clockwise direction until you reach point O and check how much inductance you will need. So if I read here correctly, I will get about 1.0, 1.1, 1.11. So I will get 1.11, so 1.11 So here it will be 1.11 So this is the required metric network, the normalized form. But you need to convert it into lump element. Remember, the frequency is 1.3 gigahertz. So you need to convert this into inductor. So 0.68 minus J and equals to J omega L. So the amount of inductance that you need is going to be, by the way, you need to denormalize it. To denormalize it, you need to divide this by 50. So you get 50 here, and then 0.68, and then omega. But omega is equals to 2 pi, and then 1.3 gig. So let me check the answer. Let's check by 50 divided by 0.68 divided by 2 divided by pi and divided by 1.3. Let's check. So I got 9 nanohenry. 9 nanohenry for this inductor. And here we need to use the capacitor. So I'm going to calculate it. I will just do it hand calculation by here. So 1 minus omega c is equals to 1.11 times 50. And from here, c is equals to 1.11 times 50 times c, times omega. So if I do it carefully, 1 divided by 1.11 and divided by 50 and divided by 2, 5, and then 1.3 divided by, right? Okay, I got 2.2 pico. 2.2 pico. In other words, I think the answer is correct. So your solution will be like this: 100 minus J40. Sorry. Yes, correct. Here 9 Renault Henry, and then capacitor 2.2 P. So this is your solution. But as I told you, there is more than one solution because you can replace this inductor with a capacitor, and you can also replace this capacitor with an inductor. The method that you need is to drag in the opposite direction. So say you are starting from point A, so you drag along the constant reactance circle in the opposite direction. So this is solution, another solution, until you meet with 1 plus Jx circle. So here you will get B palm, for example, and you need to check how much subsistence you will need. So counting from this one here is 0.1 and here is 0.6. So altogether you will need 0.5J. Okay, so this is another thing is you need to go from here and move along the 1 plus Jx circle until you meet with this point. So by just looking at the reading here, I know the inductance here, the reactance here is about 1.1. So counting from here in the backward direction, right here is 1.1 J. So in this case, I need another solution, 2 minus J point A. And here, I will need, according to here, J 0.5. And here, 1.1 J. I believe one of them is minus. So I think this is minus, okay? So let's take a look in the value, and this one will be capacitance. So 0.5 is, you need to denormalize it, divided by 50, and then omega c. And then from here, you calculate the value of the capacitance. Here, sorry, um, 0.5, 50, and then 2 pi 1.3. And then you will get the value. Let me check. Zero point 0.5 divided by 50 divided by pi divided by 1.3 divided by, so I could, let me see, 0.6 and point here is about 0.6. Yeah, I should count from here. So this is not 0.5. You should count from here, yeah. So 0.6 minus 0.18. So 0.42. So I got a little bit mistake here. So 0.42. So here, right, it should be 0.42. 42. Let's check again. Okay, make one more mistake, right? 0.5. 0.5 minus 0.18. So 0.32. So 0.32. Okay, I got it right now. 0.78 pico. So this is another solution. And inductor is this one, 1.1 J is equals to uh, omega L. So L will be 1.1, and then you need to multiply by 50. So 50, and then 2 pi 1.3 times 10 to the 9. So from here, you will get 7 nano. So another solution will be uh, will be here. Yeah, I will draw it here, and then the low 100 minus J80, J40. So here is 0.78 peak, and here will be 7 nano H. So this is another solution. Altogether, you have two solutions. One is this one, the other is this one. Okay. Uh, if you have any question, please leave your questions to the comment section of this video. I hope you can read my handwriting. It's a little bit messy, but what I have drawn here is correct. Yeah, there was some mistake here. Yeah, the wavelength should be count from this point here all the way to here. So by calculation, the total length here is 0.32 J. Okay. Okay. Thank you.